Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. What we're going to look at today is the algebra of complex numbers. Um, so without further ado, let's get straight into the algebra of complex numbers. That is our big heading for today's video, the algebra of complex numbers. And let's consider these two complex numbers here, Z1 and Z2. What we're looking at here in terms of algebra of complex numbers is just basically addition, subtraction, multiplication, and also division of complex numbers. So we're going to use these two guys here, these two complex numbers, Z1 and Z2. We're going to add them, and we're just going to go about or look at how we go about adding these two guys. If we have to subtract Z1 from Z2, how we do that, also to the multiplication of them. We want to look at the division of two complex numbers like this as well. But I want to do that in a separate video. So we wouldn't do that in this video. But we'll just look at mainly addition, subtraction, and multiplication in this video, in today's video. So let's get into it. Let's look at the first thing, which is the addition of these two complex numbers. So addition. So if we have these two complex numbers and we wanted to add them, Z1 to Z2, we will set it up like this here. You have Z1 plus Z2, and then you replace Z1 with its complex number, right? 4 plus 3i, and Z2 with its complex number, negative 5 plus 9i. So this is what we will get here. And all we simply do when you add two complex numbers, you basically add like terms. So you would take the 4, right? That is, you take your, in other words, when we say you add like terms, your real part will add to your real part, or you add or subtract your real part with your real part, you add or subtract your imaginary part with your imaginary part. So that's basically what you're doing here. So you will take the 4 and add it to the negative 5, and you will take the 3i and add it to the positive 9i. So that's what we would do. We could just rearrange this a bit and group the imaginary with the imaginary and the real with the real. So we have the real here and the imaginary here. And then we just break it down simple, work this out, work this out. And here you have it, your answer. And that's how you simply do it. That's how you add two complex numbers. You add the real parts together and the imaginary parts together. Simple. So let's just look at now the subtraction of these two complex numbers. So if we subtract, if we take Z1 and we minus it from Z2, so that would be this minus this. What we'll get, we just replace Z1 and Z2 with their complex numbers. And we have to be careful here with our little negative sign and the fact that this, the imaginary part, the real part has a negative 5. So just be careful with that in terms of the multiplication there. So this is what we have here. So we could just rewrite this, and you add 4 to 5, 4, positive 4 to positive 5, and then you have the 3i, positive 3i to negative 9i. So we could just rewrite that as this here, and that will be a final answer here. So pretty straightforward, right? So you group your real parts and you group your imaginary parts, and you add and subtract them based on your signs, right? So that's how you do it. And that's basically it in terms of addition and subtraction. So now let's look at multiplication of these two complex numbers, Z1 and Z2. So multiplication, how would we do this? Let's just write it down and let's replace these two. So when we replace them, the simple thing to do here with multiplication of two complex numbers is multiply them using the distributive rule. So you will multiply the 4, positive 4 by negative 5, and then take it again and multiply it by the positive 9i. And the 3i, you would multiply it by the negative 5, and then multiply it by the positive 9i. So that's basically a procedure. Multiply the two complex numbers using the distributive rule. And In the end, this is what we get here. Or not the end, but this is the second line. But what you'll notice when you multiply the 3i by the positive 9i, you would get 27i squared. But remember, I is equal to negative or the square root of negative 1. So if you square I squared is the same as the square root of negative 1 squared. So these are the result that we need to understand as well when you square I or cube I as well. We'll look at that a little bit later on in the video. But we need to make sure we understand that the square or this, if you square I, it is the same as negative 1. So we have to remember to replace this I squared with negative 1. So that is key there. So we would have negative 20 here. And you see, I brought my 27 with the negative 1. This is here, I just brought it down here. And our i's would have combined to give us this positive 21. And the real part would be this. This is the imaginary part. Let's just work this out here. And you will get this as our final answer here, negative 47 plus 21i. And that would be the process or your procedure where multiplication of two complex numbers is concerned. Do not forget your I squared, right? You want to remember that is negative 1, and that's basically it. But before we end the video, let's just look at simplification of I. Sometimes in multiple choice, or even could be they may decide to put it in a paper too as well. They may ask you to simplify um, powers of I, so that's very key as well. So let's just look at it. Simplification of powers of I. Let's just look at a few examples. So the first example we have is I cube. The keyword simplification of I, right, is you want to find another way of writing this. Another way of writing I cube is negative I. But what we do is we use the result that I squared is equal to negative 1. This is the same as negative 1. So you always try to bring, the key is to always try to bring I squared into play. Because we know I squared is equal to negative 1, that's what we try to do. So we bring I squared. We know that I cubed could be rewritten as I squared by I based on indices rules. And then we know I squared is the same as negative 1. So then we know I cubed could simply be written as negative I. And that's a nice little result. You can remember it. If you don't remember it, just the key is to try to employ or bring into play I squared. Let's just look at another example. I to the power of 5. So this is what we have happening here with I to the power of 5. It is the same as positive I. So you see again, we bring in the I squared. I to the power of 5 is the same as I squared, all squared, by I. By rules and indices, you will see that. And then I squared we know is negative 1. Negative 1 squared is the same as 1. And 1 by I would give you I. So that's how you have that there. Pretty straightforward. And we have one more example to look at. Right, this is a nice example here. If we look at this one, I to the negative 1 is the same as I on I squared. So you see again, we bring in the I squared into play. But we know I squared is the same as negative 1. So it is just I on negative 1, which is negative I. So this here, I to the negative 1 is the same as negative I. So simplification of the powers of I is the next thing that comes into play a lot. It's not something that is popular, but ensuring that I understand how to simplify it is very key and very noteworthy. So guys, feel free to like, subscribe to the channel, share the video to somebody that you feel it would be helpful to, and see you in the next video.